All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning calculus, or at least we're going to try to learn calculus. Because I never, so my education was kind of complicated, because of which, let's just say that my education of math specifically stopped at 8th grade. I the rest of the subjects I've managed to study them, but like specifically math, the education stopped at 8th grade. So I didn't learn stuff like trigonometry, linear algebra, calculus, stuff like that. I, believe it or not, I got into trigonometry and linear algebra years after finishing high school. Once I got into game dev, that's when I started learning trigonometry and linear algebra, and that was based on need because, well, I needed to learn it so I could understand various things. And that's pretty much how I've gone about learning a bunch of other math related things. And it's been fun. I've been meaning to learn calculus for a while now. I just never got around to doing it. And now I'm in a situation where I kind of need to learn calculus because I'm learning about neural networks for deep learning and stuff. And so, give me a second. Yeah. So, for neural network related stuff, there is quite a bit of calculus involved. So I would like to know at least the basics of calculus. So I would have some idea of what I'm doing because I'm going to be learning not just how to use neural networks, but how to build neural networks from scratch, and how to train them as well. So I want to be able to understand the calculations going on. And from what I've noticed, there's a fair bit of calculus and some linear algebra involved as well. The linear algebra part is not an issue anymore because, well, I learned linear algebra when I started doing game dev stuff. And more importantly, when I started doing shader stuff, I really had to go deep into linear algebra when I was doing shader stuff. That's actually when I learned matrix multiplication. Prior to that, I didn't know matrix multiplication, and even linear algebra. I've only studied like select few topics that were relevant to what I was doing. Because like linear algebra itself is like it's massive. I didn't intend on studying everything under linear algebra, just the stuff that I was interested in specifically. And I plan on doing the same thing with calculus as well. I just plan on studying the topics that are relevant to machine learning because I'm learning calculus for machine learning. And calculus as well it's not a small topic. It's a fairly big topic with like multiple subtopics. So I don't plan on like going all the way through with it. I only plan on studying the topics that are relevant to me or relevant to machine learning. For the time being, stuff that I do have in mind is stuff like, so I've looked into calculus a little bit already, and because I've been searching for articles on Medium specifically, so I could like read through them. And so I've touched it a little bit, but like I haven't really scratched the surface. So there's still a bunch for me to learn. I need to understand what calculus is about because so far all I've understood is that calculus is about understanding change in values. That's all I know about calculus. and I need to see what else it entails, what else comes under calculus. I know that there's you do have two subfields in calculus. You have integral calculus and differential calculus. I'm not entirely sure which of the two we're going to be going deeper into for machine learning. But like, if I'm picking specific topics, the specific topics that I'm interested in learning, because I've seen those terms being used, are differentiation, limit, partial derivatives, and what else? I guess because we're talking about calculus, so I also want to learn how to calculate the change in a value over time. I wanna understand how I can go about calculating the change. And this, I think to a certain extent, I might need to revisit something that I haven't done since well, middle school, I think, which is solving equations, because I usually don't need to do it. Like, it's just not something that comes up in any of the programming or game dev stuff that I do. I don't usually need to solve equations, so I kind of forgot how to do it. But I feel like here there might be situations where I might need to do it, maybe. So I might just touch that subject a little bit, so I can solve very basic, more specifically algebraic equations, or algebra equations, more specifically algebraic equations, equations that have x and y, a certain number of variables, and I have to sort of move things around and try and solve that equation, because it's the idea of moving things around. Like, when you move things around, you also change the arithmetic operator. So there's certain rules to follow there. I need to relearn all of that stuff, because like I said, I haven't touched it since middle school, and that must have been close to 2 decades ago, I think, or more. I don't know. But yeah, at some point I'll be touching that subject as well. For now, I've looked through a couple of calculus related articles on Medium. There have been some pretty helpful people. I mean, there's other websites that you could go to as well for learning calculus, but I wanted to stick to Medium, and I wanted to try and stick to courses that were made, or tutorials, or in this case articles that were made to teach you calculus that is specific to machine learning and data science. And this one is specific to machine learning. I think there's another one here which is specific to data science. Let me see what topics are covered here. There are certain articles which, when I open them up, I just see like an ad for a course, and it's like, oh, okay, in this course I'll be teaching you so and so, so and so, so and so, but here's the link to the course. That's not what I'm looking for. I'm looking for an article like this where I can read the whole thing. Now, what is this teaching? Let's read that. Thanks for reading. Okay. Do check out the course by clicking the link that is on Udemy. Okay, so probably this is not the one. I'm going to stick with this, because this specific course, something that I found was, this person has, they had the, was it here? No, it wasn't here. Was it here? Calculus for Everyone? I think this was the one. Yeah. So this course has four sort of articles. There's the intro itself, then there's the fundamentals of limit, then there's the fundamentals of derivative, and then there is derivative formula of a function. So these are already a a couple of topics that I'm actually interested in. So yeah, I wanna go through this thing uh, completely. We are pretty much only going to be doing theory here. I do have Python open. Um, Here's what I can do for this specific stream. What I could do is I could this small window that I usually have in the top right. Give me a second. Okay. The small window that I usually have in the top right, I can set VS Code to be there. And the window that well, the main screen that I usually have, the bigger screen, that can be the browser window, because in this stream I'm going to be doing a whole lot of reading, and I'm going to use Python to do calculations that I see in the article. So I feel like I'm going to need to. Well, yeah, okay. So looking at this made me realize that I might need to also learn how to solve equations, but I'll see. I'll see if I really need to do that. I don't know if I'm going to need to do that or not. But yeah, okay, okay. Give me a second. Let me hydrate real quick, and then we can start reading this whole thing. Okay, so hi, welcome to the Calculus for Everyone series. In this series, I will explain calculus to you, all readers of this article. I think calculus is important for everyone. Why? Because This world is ruled by calculus. The world is always changing, and it is calculus that examines that change. Okay. So, is it hard to learn? Don't worry if you feel your math skills are not enough to understand calculus, because I will try to make this discussion understandable to all readers. Even so, there are still some prerequisites. There are still some prerequisite materials that you must understand. Okay, so algebra includes linear equations, one variable and two variables, and quadratic equations. I don't remember if I know what quadratic equations are. See, because the thing is, like, with programming, or more specifically with like game dev and graphics programming and all, eventually what ends up happening is, like, you start using these terms, you start using these things, but like you don't necessarily use those terms anymore because you kind of don't really need to. And so I don't know. Hold on, let me just Google this. Quadratic equation. Wait, does quadratic equation just mean four variables? A quadratic equation is any equation that can be rearranged in standard form, as where x represents an unknown value and a, b, and c represent known numbers, where a is not equal to 0. Oh, okay. All right. And then you have linear equations. Okay, let's read the definition of that as well. Hold on. So there's a solving an equation thing, which, okay, just a second. Okay, I'm gonna do this, and I'll open it up here. Solving an equation. No, I'm looking for the Wikipedia thing, dude. You're giving me everything else except for that. Equation solving. Okay. And then let's also look at linear equation. Okay. All right. So, I'm going to switch back. All right. Okay. So yeah, I need to explore this a little more. I I'm not gonna do it like right now. I'm gonna do this like when I need to. Wait, differential equations. Is this something to do with calculus? Okay, okay. In mathematics, a differential equation is an equation that relates one or more unknown functions and their derivatives. Okay, so this is to do with calculus. Okay. Okay, yeah, a linear equation. In mathematics, a linear equation is an equation that may be put in the form a multiplied by x plus so and so, so and so, so and so, plus b equals 0, where x to xn are variables or unknowns, and b and a to an are coefficients, which are often real numbers. The coefficients may be considered as parameters of the equation and may be arbitrary expressions, provided they do not contain any variables. Okay, to yield a meaningful equation, the coefficients a to an are required to not all be 0. Alternatively, a linear equation can be obtained by equating to 0 a linear polynomial. Just a second. Wolfram. Wolfram something. Hold on. I remember Freya Homer. I don't know how her last name is pronounced, but Freya. If you look up Freya's name, she goes by Ace Gikmo on Twitch, and she's very well known for a bunch of shader and math related stuff. She's got a bunch of videos on YouTube as well, where she's explaining a lot of math related stuff. In the past, she's taught a bunch of shader related stuff. She also in the past made Shader Forge, which is a shader editor, a shader creation tool in Unity. So anyways, back when I used to hang out in her streams, she used to use something called Wolfram something. Was it Wolfram Alpha? Let me just look that up. Yeah, Wolfram Alpha. I don't know if I'm pronouncing that right. Is it Wolfram? Because I'm pronouncing it as Wolfram, but like that's kind of like, it's kind of like when you don't know the pronunciation of something, and so when you try to say it in English, you kind of just butcher it. Okay, I'll look it up later. No, I'm curious now. All right, let's look up how you pronounce this person's name. Or I don't know. Is it a person? How do you pronounce this name? Let's just say that. Pronunciation. Okay, let's see what this says. Wolfram. Okay. I don't know. Is that right? It says Wolfram. Okay, let's try another one. Wolfram. Wolfram. Okay. I guess I'll say Wolfram. I'll not say Wolfram. Was I saying Wolfram? Well, I guess I was saying it too fast for even myself to realize what I was saying. Wolfram Alpha. I'll just say Wolfram Alpha. Great, cool. So that's the platform I'm talking about. I remember she used to use it for a bunch of math related queries that she would have. I don't know exactly what this platform does, but I remember it being an engine that would, and this was like even before LLMs were a thing. I'm talking about like a good like 5 years ago. 5, maybe more. I think it was 5 years ago. A good like 5 years ago, when LLMs weren't really even that common. I remember her using this this website to search for various math related things. So my point is, I wonder if I should go try searching on this site. Also, I believe this site recently got some kind of LLM feature in it. I think so. I'm not sure because I remember reading something about it on. Man, I don't know what's going on with my voice today. I'm just not having a good time talking. My voice keeps shaking, dude. Holy shit. Anyways, yeah, I remember reading something about it getting some kind of LLM that could help users search better. Because, like, in a way, it's a good thing when these kinds of sites implement their own LLM because it makes it easier. It's so understand this: implementing an LLM on a platform that has search capabilities or a platform where people come to search for answers, implementing an LLM there is a huge upgrade in terms of searching capabilities, because then your LLM can be trained on your own data that you have on that platform, on that website. Give me a second. Yeah, your LLM can then be trained on the data that you have on that website, and then people don't need to use the search bar. They can talk to the LLM directly, and the model can give them a more organic response. So they can have a more organic conversation with the large language model, as opposed to having to search for specific terms in order to find an answer. And it also saves them the embarrassment of situations where they ask a question and then somebody on the platform decides to be an asshole, and they respond with some kind of snarky remark that, oh, you could have just Googled it, or they try to shame them for not finding the answer. I've seen that kind of shit happen on multiple platforms. At one point in time, I was a moderator for one of the biggest Unity groups on Facebook. One of the biggest. I'm not even kidding about that. It was one of the biggest and most active Unity communities on Facebook. Unity Facebook groups. And even there, I saw the same thing. I've seen the same thing happen in Discord, in places like, for example, this kind of sounds like shaming, but like I've seen this happen on the VR chat side as well. with like creators, when somebody is asking a question, you'll occasionally get certain people that'll give like uh they'll be a dick about it with their response. And I think part of it is because like over the years of helping, like obviously these people do help, but like over the years of doing that, I think they become kind of jaded, and eventually like it just, they forget that beginners exist. They forget that a person who's a beginner, not only will they not know about, this thing that they're trying to learn, which is why they're asking the question, but there's a decent chance that they also don't know how to search. Because prior to getting into Unity, I'm not even kidding about this. Prior to getting into Unity, and this was like, I had been doing C# programming for a good, I don't know, 2-3 years, maybe 4 years, I think. But prior to getting into Unity, I got into Unity, I think 3 to 4 years after I started learning C#. Prior to getting into Unity, I did not know how to search for answers. I did not know how to Google stuff. I mean, I knew that Google existed. It's just that it's not one of those things that came into my head that, oh, hey, I need this answer. Maybe I should look it up on Google. Maybe somebody else might have asked the same question. Maybe somebody else might have had the same problem, and somebody else might have already answered that question, right? They might have already solved that problem. It's just not one of those things that occurs to you, which is why I really wish they would start teaching in certain ways. They would start teaching in schools how to find answers, how to look for answers, because this is a very useful skill. I've been a programmer for more than a decade, okay, and even now I would say, like, you should never stop Googling stuff. You should never stop like looking for answers, because you can't know everything. Not only that, there's always a chance that you can learn something, even if you know a lot about that topic. If you look it up online, there's a decent chance you're going to find some extra information, and there's no shame in looking it up. Like I said, I've been programming for more than a decade, and even now I Google stuff. It's just, it saves you a ton of time. It saves you a ton of mental stress. You don't have to try and reinvent the wheel each time. Wow. Okay, that was quite a tangent. So we are gonna jump into calculus, but let me drink some water, and then we can start. Oops, something happened there. What just happened? Okay. All right. So, introduction to calculus. Where was I? Don't worry if your math skills are not. Wait, no. I read this already, right? Okay, so the prerequisites are algebra, including linear equations and quadratic equations. I think I'll read that off stream just to kind of refresh my knowledge. Because, one of the reasons I really want to go deeper into this to understand the math is because I want to be able to solve these things manually. Like, for example, solving, I don't even know if this is accurate to say, but like solving a perceptron. Let's say that. Solving, not solving, but like being able to write down on paper the calculations for, let's say, two inputs going into a perceptron, and then or let's say three inputs going into a perceptron, and then there's a bias, and then after you get that intermediate value, you pass it through an activation function. So then there's a calculation for the activation function as well. I want to be able to do these calculations on paper. Obviously, if it's a bigger neural network, then like, you're not going to be doing it on paper. But I want to be able to do like these simple, smaller calculations on paper because it helps me understand things better. But like, to be clear, it's not necessary for me to, like, the idea isn't for me to be able to do it on paper. The idea is for me to be able to do it manually, be able to do like the smallest unit of calculation manually, just so I can understand like bits and pieces of it. And then once I've understood that, I can then kind of expand that. I can like scale it. I can scale those calculations using something like Python, for example. And okay, there's an ad playing, so I'll see you guys in 30 seconds.
شاهد الفيديوهات بدون انقطاع مع يوتيوب بريميوم واندمج فيما يعجبك سواء كان ذلك هوايتك المفضلة أم شغفك الجديد.
All right, welcome back. So yeah, I wanna be able to solve certain certain problems. I was kind of mixing up my words, but solving calculations. I don't know if that made sense, but yeah, I wanna be able to do these calculations on paper or manually to a certain extent. Obviously, as your neural network becomes bigger, doing the calculations on paper is going to become more and more tedious, and it's at a certain point it's just kind of wasteful. And I don't need to do that, especially since I can do that with Python easily, like doing the calculations from scratch, but not having to write down everything manually on paper. I can just use Python to do those same calculations manually. So anyways, yeah, I'm gonna read up on linear equations and quadratic equations. Then the ability to read graphs. Okay, I know that. And then the inverse function. The inverse function, it's kind of interesting because like inverse values, or getting the inverse of a value, it's something that I've done in other scenarios, but like I don't know what the inverse function would mean like in the context of calculus. So I'm gonna have to see what that entails. As you can see in the list above, the only thing you really need to master is algebra. Not too difficult, is it? Nope, it's not. Algebra is something that I'm well versed with. But like even in algebra, solving is something that I'm not. How do I put this? The idea of solving where you have to like move variables around in order to solve the thing. If I don't have to move variables around, if it's just about like arithmetic precedence, then it's a different thing, right? Something like PEMDAS, for example. Even if I forget PEMDAS, which I remember PEMDAS because I've heard a couple of other people say it, I don't think we learned it as PEMDAS. We probably learned it as something else, but I completely forgot about that. And then I relearned about arithmetic precedence once I got into programming, because then I learned that, yeah, even in programming, there's going to be arithmetic precedence when you have multiple arithmetic operations taking place in the same line, in the same expression. But there is a way, and this is where I got lazy, because there was that way. So I didn't bother with PEMDAS, and even now I don't usually bother with PEMDAS. One of the great things about, like, when it comes to arithmetic precedence in programming is that you can isolate expressions using parentheses, so you don't always need to worry about arithmetic precedence. If you have like the slightest doubt that the calculation might not be in the order that you want it in, just start putting everything into parentheses. So everything becomes like its own expression, and there's like a bunch of nested expressions. So the innermost one is going to be solved, and then the one outside that will be solved, then the one outside, then the one outside. And so eventually you're able to do your calculations. You're able to set the arithmetic precedence how you want it to be. And so you don't need to worry about arithmetic precedence then. Okay, so let's carry on with this. What will I learn? Here you will learn all calculus material from beginner to advanced level. I will also provide a discussion on the related problem set. No, of the related problem set. Okay, I'm not sure what the problem set is here. Okay, in general, here is the calculus material you will need to learn. That you will learn. Derivative, integral, differential equation, and calculus in real life. Okay, is this material only for students? No, this material is not just for students. Everyone can read the material and questions that are here. I have also adapted my writing style to suit everyone, student or not. However, it is important to remember that you must dedicate your time to studying calculus. Calculus is not something that can be mastered in just one day, so prepare your time. All right, cool. Yeah, that's understandable. You need to practice the thing to understand it and to get better at it. Is there a book that, okay, yeah, this is references to books. So, okay, you know what's interesting? I mentioned that I learned trigonometry based on need. So there are bits and pieces of it that I didn't learn. But also, it's worth noting that when I learned about trigonometry, the way that I approached it was by learning about the unit wheel. So if you take, how do I put this? If you take a wheel with a radius of 1, if you take a circle with a radius of 1, within that circle, from the center of the circle to the edges of the circle, you can plot lines that will represent various trigonometric operations, like sine, cos, tan, and the others. There's a few more, like I think four or five more. Maybe I should just show it to you. And this is a very good way of learning trigonometry versus the way that I saw other people being taught in school, which, I mean, they approach it from a different angle, but I felt like the unit circle method was great because it helps you visualize. It really helps you visualize what exactly is going on, and it helps you understand why, when you pass a certain value into a sine function, why exactly you get a certain value back. Generally, when you pass a value into a sine function, it returns a value between -1 and +1, right? if you look at the unit circle, oh, it's the same for cos, by the way. For it's for sine and for cosine. When you pass in a certain value, which will be usually in radians, if you pass in a certain value, it's gonna return a value between -1 and +1. And as you keep increasing that value, you'll start to notice a sort of wave-like behavior in the numbers. Believe it or not, like sine and cos, in fact, trigonometry, it's used for like a lot of stuff. Sine and cos, especially, like if you ever see like a waving kind of effect, or a wave kind of effect, or like a smooth hovering and like up and down kind of effect, there's a decent chance that they've used, unless it's like pre-made animation, if it's being done real time through scripting and stuff, there's a decent chance they're using trigonometry in some way to move it, because like trigonometry allows you to do that. Like in the simplest form, it allows you to do that. Let me show you. Oh, the music stopped.
لن تستمع لنفس الأغنية مرتين إن لم ترغب بذلك. احصل على يوتيوب ميوزك بريميوم.
Okay, trigonometry, unit circle. I'm looking for the Wikipedia thing. Okay, yeah, there we go. This is what I'm talking about. So if you look up unit circle on Google, then you'll find this Wikipedia entry, and this is what I'm talking about. So like on a circle, which I believe the radius is 1, because that is why you're able to get -1 to +1. I believe it is 1. I believe the radius is 1. In fact, yeah, that's where you get unit from, right? So yeah, anyways, you are, as you can see here, you can plot lines on here to find various trigonometric functions, or find the answers for various, I'm not sure what terminology to use there, but yeah, as you can see over here, you're also getting sine and cosine. And as you increase, so when you pass in, let's say you start at 0 over here, I think this would be 0. If you start at 0 over here, and let's say we're talking about in degrees, you can, there's usually some constant that you can multiply the degrees value by to convert it to radians, and vice versa. There's also a constant that you can multiply radians with to convert it back to degrees. Usually it's called degrees to radians and radians to degrees. Or there might be a function that says, you know, it might be called radians, and you pass in the degrees value and it'll give you the radians. Anyways, so something you'll notice is, let's say you start with 0 degrees, which is here, right? Sine is going to be, I believe, 1. Sine would be on the y-axis. So yeah, sine would be 1. And then as you increase and you bring, I don't know if my mouse cursor is visible. Let me see on stream. Hold on, I can't see if my mouse cursor is moving. Hold on. Yeah, okay. So my mouse cursor is here. So as you keep increasing, and like you can count in radians if it's easier for you, but like I'm counting in degrees. So let's say you start counting like from 0 and you keep going like this. And so by the time you reach here, you're at 90 degrees. And then by the time you reach here, you're at 180, and then 270, and then 360. As you keep counting, you can actually see the sine values and the cos values changing. And then if there's any of these others, I haven't used a bunch of these others a whole lot more. I actually haven't used any of them at all, for that matter. Like, I just haven't had the use for them. But I've had a lot of use for sine and cosine, a tiny bit of use for tan. But okay, my point with saying this was, I mentioned before that I studied trigonometry based on need. So I basically only studied what I needed to study. I didn't study like all of trigonometry. So like a bunch of these functions, I still don't know how to do them. There's like basics of triangles that I don't know, like in terms of how the calculations are meant to be done for triangles, like sides and stuff like that. So there's a bunch of this stuff that I still don't know. I don't remember why I was telling you that there's a bunch of the stuff that oh yeah, okay, so here's a demonstration of it. I didn't notice it before. But yeah, you can see what I was talking about here. So you can see sine and cosine changing. I don't remember what this would be, but like, actually this wouldn't be anything because the value is constant. It remains at 1. Yeah, so anyways, let's carry on with this. So we are done with this. We're going to move on to the fundamentals of limit. Okay. So what is limit? Basically, the meaning of limit in mathematics is the same as the meaning of limit in the real world. Limit means boundary. What does it mean? Just as a reminder, in the function so-and-so, x is called the domain and 2x plus 3 is called the codomain. Alright? Now, in the concept of limit, we limit the value of x, which is our domain, to approach a value. Let's call it a value of a. We limit the value of x to approach a value. Let's call it the value of a. Give me a second, let me hydrate. Okay, we limit the value of x to approach a value. Let's call it the value of a. I'm not getting it. Why just approach? Why don't we just write x equals a? This is because in some math and physics problems, sometimes we cannot substitute the value of a into the variable x. For some reason, sometimes we can only calculate the value of a function whose x value is close to the value of a. We can only calculate the value of a function whose x value is close to the value of a. What is an example? Try to solve the following equations. Dude, okay. I don't know how to solve equations, dude. Okay, I'll just carry on with this. What is the value of y when x equals 1? If you calculate it correctly, nope, I didn't calculate it at all. You will find the result is y equals 0 by 0, which means the result is undefined. True, the result is undefined. Well, this is where the concept of limits works. We can't calculate the value of y when x equals 1. but we can calculate the value of y when x approaches 1. The word approach here means the value of x is very close to 1. It can be interpreted that the value of x approaching 1 is equal to 0.9 or 1.0001. Okay, so a tiny bit below 1 or a tiny bit above 1. Both values are so close to 1 that they represent the value of y when x is equal to 1. Okay. In the graph above, we can still see the value of y at x equals 1. We can see the value of y when x equals 1. The value of y is 2, isn't it? Yeah, okay. Because that value is the limit value, namely the limit of y when x approaches 1. The value of y equals 2 is not the exact value when x equals 1. When x equals 1, the value of y is still undefined, but we can use the limit value. Okay. Oh, that's interesting. Why does that happen? We cannot say that the value of y equals 2 when x equals 1. But actually, the value of y is undefined when x equals 1. However, we know that when the value of x is very close to 1, the value of y is very close to 2. To express this, mathematicians use the concept of limit. So the above statement can be expressed as the limit of y as x approaches 1 is equal to 2. And we can write it as follows. Limit of y as x approaches 1. Oh, okay, so this is how you write it. So the limit of y as x approaches 1 is equal to... Oh, here they're solving the thing. Okay. Lim stands for limit, and x approaches 1 means the value of x is close to 1. Here's the general form of the limit concept. Limit x approaches a, f x equals k. The above equation means the limit of f of x as x approaches the value of a. I'm having trouble understanding the concept of like approaching. I also haven't fully understood why it's undefined here. I guess we can carry on reading and I'll get it eventually. No, let's try reading this. Let's try reading it again. If you calculate it correctly, you will find that you'll find the result y equals 0 by 0, which means the result is undefined. Oh, could it be that this is meant to represent the fact that x is at 1? Like, is this meant to represent the fact that x is at 1? And so then we're supposed to calculate the value of y using this equation, using this formula. And then because this formula gives us 0 by 0, so that is why. So like, because when we look at it, it looks like x is at 2. No, it looks like x is at 1 and y is at 2. But when we calculate it mathematically, is it that we get an undefined value? Is that what's going on here? Because like I've never tried calculating it mathematically. Because like when I look at a graph, like I see the values right there, right? I've never tried to like. No, I'm trying to imagine situations where, like, in what situation would, oh, what is the value of y when x equals 1? What is the value of y when x equals 1? The value of y when x equals 1 I'm just trying to I'm trying to imagine under what circumstances would the value kind of change, because like I guess it would depend on what the slope looks like, right? What this line looks like. So if the line is passing through this, so like if you look at it here, it's not passing through 0, right? So because it's not passing through 0, so we can't really say. And also, like, I mean, yeah, okay, so, oh dude, slopes is another thing that I had been meaning to look into, because like I've seen the concept of slope coming up in linear regression. Actually, I've seen calculus coming up in linear regression as well, for that matter. I never really finished learning linear regression. I read up on it a lot, but then each time some of the calculus stuff would come up, and actually each time some of the slope stuff would come up, I would start searching on those topics and I would just kind of get lost in that, and I wouldn't move forward with it too much. I would just kind of get distracted and go do something else. Simple stuff like calculating the slope. Like I've worked with graphs before, but like not from this angle. So like when they say the slope of a line, and other like similar topics, I have trouble like understanding that because I haven't really studied that. So I think I need to add that to my list. Finding the slope of a line. I think that's what it was called. Okay. In the graph above, so we're going to read this again. In the graph above, we can still see the value of y at x equals 1, because that value is the limit value, namely the limit of when x approaches 1. The value of y equals 2 is not the exact value when x equals 1. When x equals 1, the value of y is still undefined, but we can use the limit value. So what I don't understand is why is the value of y undefined? Like, what makes it undefined? Is it the fact that we are trying to get the value of y? Oh, is it that we are using this equation? Is that the reason? We are using this equation to... Oh, shit, dude. That just occurred to me. Oh, man. Okay. That just occurred to me. Alright, so let's try this out. Right, x squared minus 1. So it would square first, right? Yeah, it would square first, right? and then minus 1, and then x minus 1 is 0. And oh yeah, that makes sense. That makes sense. So x square 1 is 1, 1 minus 1 0, and then x minus 1 is also 0. Okay, okay, now I'm getting it. Now I'm getting it. But for this specific line, like how do we know where the line is supposed to start from? Why does it not start from 0? Like, what is going on there? Is it just like an arbitrary line that gets drawn? And like, if it's an arbitrary line, how would you represent that within the formula? I think I need to learn about. Should we do that right now? See, this is what happens when I try to do when I start doing like my math research. I just get distracted with a bunch of different topics. So we're just going to be jumping topics a whole bunch during this stream, however long the stream goes. Finding the slope. Okay, slope of a line.
مع ميوزك بريميوم ليس هناك إعلانات، ما يعني لا فواصل في أغاني طفلك. احصل على يوتيوب.
Okay, so I guess what I'm having trouble understanding is how do we define where the line is on the graph? Because like I know that a line has 2 points, right? There's a starting point and an ending point. But like in the case of these kinds of, wait, are these the same page? Yeah, they are. Okay. In the case of like these kinds of scenarios, it seems like the line can be infinite. It doesn't necessarily have to start and end somewhere. It just needs to be passing through certain points where we are doing our calculation. So it's like an infinite line. Now I need to like understand how this is being represented in math. I need to be able to visualize this. Okay, so in mathematics, the slope or gradient of a line is a number that describes both the direction and the steepness of a line. Okay, so the slope defines the direction and the steepness of the line. So the steepness helps. Understanding how steep it is helps. And I'm guessing this is where degrees are going to come in, because like that's how you would like specify the steepness, right? You would rotate the line, but like how do you find the axis that you want to rotate it around? Or rather, I mean, no, you have the axis. How do you find the pivot point to rotate the line around? Anyways, let's keep going. Slope is often denoted by the letter m. There is no clear answer to the equation why the letter m is used for slope, but the earliest use, and I don't, it's fine. So-and-so who wrote the equation of a straight line as y equals mx plus b. And it can also be found in so-and-so who wrote y equals mx plus c. Now, okay, y equals mx plus b is something that I've seen quite a bit when learning about the slope. Okay, slope is calculated by finding the ratio of the vertical change to the horizontal change between any two distinct points on a line. Dude, I forgot how you calculate ratios, dude. Let's just revisit that. Wasn't there like division involved there? In mathematics, a ratio shows how many times one number contains another. For example, if there are 8 oranges and 6 lemons in a bowl of fruit, then the ratio of oranges to lemons is 8 to 6, but this can be simplified down, right? Okay, similarly, so the idea with ratios is it's like dividing. Well, no, it's not dividing. Dividing comes in when you're simplifying it, right? The ratio is just like comparing. But then you have to like simplify it down if you want to say for every one this, we have that many of that. So like when you say water to juice 1:2 ratio, you're saying for every 1 cup of water, it's 2 cups of juice. But okay, so I know about that. And to a certain extent, I know how to calculate the ratio as well. I think I need to revisit this again. But like, I also need to understand how that fits into this scenario, how it fits into slopes. So we're gonna go back to this. Similarly, the ratio of lemons to oranges is 6:8 or 3:4, and the ratio of oranges to the total amount of fruit is 8:14. Wait, how do you get that? Hold on. I lost count of how many fruits were there. Okay, so oranges to lemons. So that's 8 oranges, 6 lemons. Then you have 6 lemons, 8 oranges. Oh, total amount of fruit. Oh, okay, shit. For whatever reason, reading this, I somehow started to think there was a third fruit in there. But no, yeah, the ratio of oranges to the total amount of fruit is 8:14. So yeah, it's just a matter of writing it, like putting it down in writing. The ratio is this many of this to that many of that. And then if you want to simplify it down, then you can just start dividing the numbers. And I think you have to stop when one of the numbers is not divisible, is not divisible anymore. Though, do we have to stop at 4:3? Do we really have to stop there? I mean, we have to stop if we want to keep the numbers as integers, right? But then what if we could like keep dividing it as float numbers? To be fair though, if we did divide it further down, it could go infinitely. So I don't think that's gonna accomplish much. Keeping it as integers, it kind of limits how far you can go, and you can't divide, like you can divide 2 further, to get another integer, but you can't divide 3 further to get another integer. You'll get a float, a decimal number. So 1.5 basically. Okay. Okay. The numbers in a ratio may be quantities of any kind, such as counts of people or objects, or such as measurements of lengths, weights, time, etc. In most contexts, both numbers are restricted to be positive. A ratio may be specified either by what just happened? Oh, okay, mouse. Yeah. A ratio may be specified either by giving both constituting numbers written as a to b or a colon b, or by giving just the value of their quotient. Really? Is that a thing? So like that's a single value then, right? Equal quotients correspond to equal ratios. A statement expressing the equality of two ratios is called a proportion. Consequently, a ratio may be considered as an ordered pair of numbers, a fraction with the first number in the numerator and the second and okay, I don't think I need to read any of this other stuff. Is there anything more I need to look into? These are all definitions and a history, number of terms and use of fractions. In general, a comparison of quantities of a two-entity ratio can be expressed as a fraction derived from the ratio. For example, a ratio of 2:3, the amount of size, volume, or quantity of the first. No, in a ratio of 2:3, the amount, size, volume, or quantity of the first entity is 2:3. 2 divided by 3. Oh, wait, no. Hold up. The amount, size, volume, or quantity of the first entity is 2/3 that of the second entity. Really? I never thought about it in that way. Let's read that again. The amount, size, volume, or quantity. Okay, so let's just say quantity for the sake of simplicity. The quantity of the first entity is 2/3 the size of the second entity. So like if we take 1:2, 1:2 is, well, half, and 1 is half of 2. If we take 3:6, nope, hold on. Okay, hold on. If we take 3:6, what happens there? I mean, 3 is not 3/6. Wait, no, 3/6 isn't 3/6 half? No, is it? What would 3/6 be? Yeah, 3/6 is half, isn't it? 3/6? Yeah. 3/6 is, well, 3 parts out of 6 parts, so that's half. Okay, that makes sense. I think I'm imagining it right. I think so. Okay. If there are 2 oranges and 3 apples, the ratio of oranges to apples is 2/3, and the ratio of oranges to the total number of pieces of fruit is 2/5, or 2:5. These ratios can also be expressed in fraction form. There are 2/3 as many oranges as apples, and there are 2/5 as many pieces of fruit.
بلا إعلانات بتشغلها بدون
No,
والاستمرار في تشغيل أغانيك المفضلة في الخلفية. احصل على
there are
يوتيوب ميوزك بريميوم
there are
جميع
two-third
الإعلانات.
as many oranges as apples, and two-fifth of the pieces of fruit are oranges. If orange juice concentrate is to be diluted with water in the 1 to 4 ratio, then 1 part of concentrate is mixed with 4 parts of water. Okay, giving 5 parts total. The amount of orange juice concentrate is 1/4 the amount of water. That makes sense. Yeah, that makes sense. It is 1/4 the amount of water, because the first part is 1/4 of the second part. That makes sense. Yeah. I'm trying to imagine how this would work for like bigger numbers. Would we say, let's say, if it was, let's double it. Let's say if it was 5/20th. So 5 parts. If it was 5 parts, or let's say 4 parts. If it was 4 parts orange juice and 20 parts. Oh, sorry, I got distracted in something. If it was 4 parts orange juice and 20 parts water, would we say it is the amount of orange juice is then 4/20th of the water? I mean, usually we don't say that. Usually we stick to like smaller numbers. So I guess then we would be dividing it down, right? So let's divide it down. It's 4/20, right? Oh, 4/20. Nice. Okay. So it's 4/20. Divide 4 into 2. Divide 20 into 2. So you get 2/10. And then 2 can be divided down further. So you get 1. So 2 divided by 2, 1. 10 divided by 2, 5. So then you get 1/5. So 4 parts orange juice and 20 parts water is, it basically means that the orange juice is 1/5 of the water. Okay. All right. Have I not been hydrating? Give me a second. Let me hydrate. I've just been lost in my thoughts. And so I think I just completely forgot to hydrate. Okay. Okay. Fractions can also be inferred from ratios with more than 2 entities. However, a ratio with more than 2 entities cannot be completely converted into a single fraction, because a fraction can only compare 2 quantities. Yep, that makes sense. a separate fraction can be used to compare the quantities of any two. Okay, I don't think I need to do that. Like, the stuff that I'm doing is not going to be that level of complex, so I don't need to go into that. Okay, proportions and percentage ratios. If we multiply all the quantities involved in a ratio by the same number, the ratio remains valid. Okay, good to know. Good to know. I just realized something. I forgot to close something that I had open that must have been... Wait, what's going on here? Hold on. Just a second. Give me a second. Okay. Yeah, let me check if the music is still going, because I think it must have stopped. Yep, it did. Okay, let me skip the ad. I hope YouTube didn't play any, full copyrighted tracks during one of its ads. I can just hope. But yeah, let's carry on. Okay. So, where were we? For example, a ratio of 3:2 is the same as 12:8. It is usual either to reduce terms to the lowest common denominator or to express them in parts of 100%. Okay, if a mixture contains substances A, B, C, and D, the ratio is not... I don't think I need to go into this. I mean, I can kind of like picture it. I don't think I need to go into this. Yeah. Reduction. Ratios can be reduced by dividing each quantity by the common factors of all the quantities. As for fractions, the simplest form is considered that in which the numbers in the ratio are the smallest possible integers. There you go. Okay. Thus, the ratio 40:60 is equivalent in meaning to the ratio 2:3. Okay, that makes sense. Because these can be divided down, right? 20. No, so 40, 20, 10, 5. Wait, no. Hold up. Wait. Forty, 20 is... Hold up. Okay, so 40:60 is equivalent in meaning to the ratio 2:3. But like, okay, hold up. So if we divide 40 by 2, we get 20. We divide 60 by 2, we get 30. So it's 20 to 30. Then we divide, I'm like reducing this down, right? Okay, so what is it? 20, 30. So we divide 20 by 2, we get 10. 30 by 2, we get 15. But then we can't divide it down further. So we end up with 10 by 15. Okay, but then if we do it the other way around and like directly divide it by like a bigger amount, then we end up with a smaller amount. That's interesting. Hold on. Okay, so 10, 15, right? 10 can go down to 5. And then 15 can go down to 7.5. But like it's now already a decimal, right? And then 5 goes down to 2.5. And then 7.5 goes down to 3.75, I think. Would it be 3.75? I think so. So we get 2.5 and 3.75. But then... Wait, hold on. Let me read this thing. Mathematically, we write this is equal to this, or so and so, so and so. A ratio that has integers for both quantities that cannot be reduced any further is said to be in its simplest form. Right, but like that is interesting, because like I tried to break them into half each time and that didn't work to simplify it, but then breaking it into multiple parts kind of helped this situation. So like 40 divided by 20, it gives you 2. You know what? I guess the idea is to just get to the smallest number, right? Maybe we don't need to like break the thing down. We don't need to further keep dividing. We don't need to further keep splitting it. The idea is to just break it down. Break it down to like the simplest number that you can find. I think so. Okay. Anyways. Sometimes it is useful to write a ratio in the form 1:x or x:1, where x is not necessarily an integer, to enable comparisons of different ratios. For example, 4:5 can be written as 1:1.25, dividing both sides by 4. Alternatively, it can be written as 0.8:1, dividing both sides by 5. Where the context matters, the meaning is clear. No, where the context makes the meaning clear, a ratio in this form is sometimes written without the 1 and the ratio symbol. Though mathematically this makes it a factor or multiplier. Okay. So, moving on to this. So, slope is calculated by finding the ratio of the vertical change to the horizontal change between any two distinct points. Now, how do you find the change? Because I'm seeing subtraction here. Are we just picking 2 points and we're like, okay, from this point, I mean, like that's one way to find the change, but like I thought there would be something a little more complex involved. Because like, okay, if we are trying to find how much something has changed between 2 points, we can just subtract it, right? You get the difference and like that's the change. But like I never imagined that that's how it would be. I never imagined that that's how, like, they would call that the change of the value from this point to that point. Because I think it's because I'm just used to calling it difference. So you get the ratio of the vertical change to the horizontal change between any two distinct points on a line. Sometimes the ratio is expressed as the quotient rise over run. Anyways, is expressed as a quotient giving the same number for every two distinct points on the same line. Oh, there's an ad playing. I'm gonna hydrate and I'll be right back. Alright, welcome back. Okay, two distinct points on a line. Sometimes the ratio is expressed as a quotient giving the same number for every two distinct points on the same line. A line that is decreasing has a negative rise. The line may be practical as set by a road surveyor or in a diagram that models a road or a roof either as a description or as a plan. The steepness, incline, or grade of a line is measured by the absolute value of the slope. Okay, what is an absolute value? In mathematics, the absolute value or modulus of a real number, denoted by so-and-so, is a non-negative value of x without regard to its sign. Oh shit, I forgot. Absolute value. Yeah. The absolute value. Holy shit. Yeah, okay, so we use like this is basically mathf.abs. It's the absolute value when you want to get how does modulus come into this? But yeah, the absolute value is basically when you want to ignore the sign. So if it's a negative number, it's going to be positive. If it's a positive number, it's going to be positive. Okay, a slope with a greater absolute value indicates a steeper line. A slope with a greater absolute value indicates a steeper line. Okay. The steepness. Oh, okay. Wait, how do you calculate the steepness though? Okay, the direction of the line is either increasing or decreasing. No, increasing, decreasing, horizontal or vertical. A line is increasing if it goes up from the left to the right. If it goes up from the left to the right. Okay, that makes sense. So going from negative x negative y to positive x positive y, the slope is positive, i.e. m greater than 0. Okay. A line is decreasing if it goes down from left to right. The slope is negative, i.e. m less than 0. Okay. If a line is horizontal, the slope is 0. This is a constant function. If a line is vertical, the slope is undefined. Okay, the rise of a road between... Is road supposed to mean something here? Okay, let's carry on. The rise of a road between 2 points is the difference between the altitude of the road at those 2 points. How do you calculate the altitude? Hold on. Or altitude. Is the difference between the altitude of the road at those 2 points, say y1 and y2? Or in other words, the rise is y2 minus y1 equals change in y. For relatively short distances where the Earth's curvature may be neglected, the run is the difference in distance from a fixed point measured along a level. Along a level, horizontal line, or in other words, the run is x2 minus x1 equals... Wait, hold up. Hold up. So the rise would be change in y, and the run would be change in x. Wait, is the music still going? Yeah, let's just click on that page again. Okay. So I'm kind of getting lost here. What exactly was the... what is that called? Rise over run. Okay, the rise of the road, the rise of a road between 2 points is the difference between the altitude of the road at those 2 points. Say y1 and y2, or in other words, the rise is y2 minus y1 equals change in y. So we basically calculate the altitude between. Hold on. I keep getting hung up on like stupid ass pronunciations. Hold on. Because I've heard both being pronounced, and for some reason, each time I say the word, my mind keeps like getting distracted with like, am I saying that right? All right, fine. We're sticking with altitude. Fine. Great. English is a weird ass language, dude. Holy shit. Where was I? Okay. The altitude of the road at those 2 points, say y1 and y2, or in other words, the rise is for relatively short distances. The run is the difference in the distance from a fixed point measured along a level, a horizontal line, or in other words, the run is
الموسيقى بلا إعلانات
x2 minus x1 equals change in x. Okay, so the rise is measuring the change in the slope's y value, and the run is measuring the change in the slope's x value, or the line's x value. That's what I'm getting from this. Here, the slope of the road between the 2 points is simply described as the ratio of the altitude change to the horizontal distance between the 2 points on the line. The horizontal distance. How do you measure the horizontal distance? Because like, okay, I'm trying to imagine the horizontal, like measuring the horizontal distance of a diagonal line that's plotted on like x and y axes. Yeah, I'm trying to imagine how you would measure the distance when you have, because like if it's a straight line, then you can just like measure the distance, right? But like if it's a diagonal line, would there be like a different way of measuring the distance, or like would you be right to just measure the distance as if you were measuring it as a horizontal line? Okay, here the slope of the road between the 2 points is simply described as a ratio of the altitude change to the horizontal distance between any 2 points on the line. Any 2 points on the line. Wait, in mathematical language, the slope m of the line is m equals change of y minus change of y divided by change of x. The concept of slopes applies directly to grades or gradients in geography and civil engineering. Through trigonometry, the slope of a line is related to its angle of inclination theta by the tangent function. Thus, a 45-degree rising line has a slope of +1, and a 45-degree falling line has a slope of -1. As a generalization of this practical description, the mathematics of differential calculus defines the slope of a curve at a point as the slope of the tangent line at that point. When the curve is given by a series of points in a diagram or in a list of coordinates of points, the slope may be calculated not at a point but between any two given points. That makes sense, because like the line, it's a line. It's not like it's not a curve. It's a line, so it's always straight. So no matter where you measure, like which 2 points you pick, you're always going to have like the same slope. Wait, like would the direction change depending on the order of the 2 points that you pick? Dude, I need to do this practically. I need to do this on paper so I can imagine the thing, so I can visualize it. I need to read up on this much more. The slope of a line in a plane containing the x and y axes is generally represented by the letter m and is defined as the change in the y coordinate divided by the corresponding change in the x coordinate. Oh, that's what we did up here. So is this the equation that you get when you try to solve y equals mx plus b? Where does b come in here? Oh shit. Accidentally hit end. Let's go back up. Also, I'm wondering if I should go back and try to learn these extra functions. So I learned this. This is the interesting part. Like with trigonometry, I learned it, but like I had a doubt. I always had a doubt about like how they go about measuring the triangle. Like how do they go about creating that triangle? What calculations are they doing in order to be able to plot this triangle? That was something that I never got around to doing it. I just need to take out the time to go and read how exactly the triangle gets formed. Where exactly, from where to where are they measuring in order to get the triangle's shape? Because it seems to me like it's so okay, it's a triangle. Within this triangle, it seems like there's always one right angle. Pretty much always there's at least one right angle. Isn't that right? Hold on. Let me just look at a visualization. Yeah, if you look here, there's always a right angle here. So I guess that's one thing that I could build off of. That would be a starting point. So that's one of the characteristics of like how exactly they're forming this triangle. But yeah, okay, that's trigonometry. I need to take out some time for that later. Where was I? Here. Okay. Okay, so it's represented by the letter m and is defined as the change in the y coordinate divided by the corresponding change in the x coordinate. Okay, between two distinct points on the line that is described by the following equation. So something I need to keep in mind here that is that the line is always straight. It is a line, it's not a curve. So any points, any 2 points on the line are probably always going to have, like I can pick any 2 points. I don't need to worry about there being like different. I don't need to worry about there being like different values at different points of the line, at least in terms of calculating the slope, because the line is always straight. All right, the slope of a line in coordinate system. From f of x equals negative 12x plus 2 to f of x equals 12x plus 2. Okay, how is this being calculated? Wait, wasn't that y equals mx plus b? Wait, does that apply? Is that applying here? I'm not sure. Okay, let's read further. So m equals the change in y minus divided by the change in x. How are we getting oh, so each time we change, let's say we get any 2 points on the graph, we can then calculate that slope. Let's say we have 2 points already, and then we create 2 new points. So then now we have we have a set of old points and a set of new points. So now we can subtract them, and then we get the slope of the new one. But like this is a slope relative to the previous line. So the slope is telling us how much it has changed, basically. Okay, let's carry on. The Greek letter delta is commonly used in mathematics to mean difference or change. Given 2 points, okay, the change in x from one to another is so and so, and that's called the run, while the change in y is so and so, and is called the rise. Substituting both quantities in the above equation generates the formula this. The formula fails for a vertical line, which is parallel to the y-axis. Oh, because it's dividing by 0? Okay. Okay. Wait, how is it dividing by 0? It fails for a completely vertical line. But like, if this was a slope, I mean, if this was the line and, okay, so this is the line. No, this, nope, okay, okay, this, fuck's sake, dude, go to 0 already. What are you doing? Okay, didn't go to 0. Great, awesome. Okay, the formula fails for a vertical line. I guess I'll have to do the calculation myself to see why it fails. Parallel to the y-axis, where the slope can be taken as infinite, which, I mean, visually, yeah, that does make sense, right? There is no slope there. So the slope of a vertical line is considered undefined. Okay, that makes sense because there's no slope. But like I'm thinking about it visually. It's a straight line. There's no slope there. I'm trying to understand how I get to this answer mathematically. Especially if we are talking about change from one value to another or from one line to another. Because like both of them are not going to be zero, right? One of them is going to be zero. I'm trying to understand how this formula would fail if, let's say y2 is the current one, right? y2 is 0. x2 is also 0. Wait, no. How is y2 0? How is y2 0? If I pick any 2 points, I mean, yeah, okay. y2 could be 0, but like more importantly, x is what's 0 here. That's why it's a vertical line. So let's say, fine, y2 and y1 are both valid, but x2, which is the current one, is 0, and x1 was a positive 1. And so if we subtract them, the change comes out negative. Dude, I think I'm missing something here. I need to read this again. Suppose a line runs through 2 points. I think I need to draw this out. Yeah, I think I need to draw this out on on paper. Maybe then I'll understand. Okay, suppose a line runs through 2 points. P equals this and Q equals that. Okay, by dividing the difference. Wait, have I been imagining this? Have I been like picturing this wrong? Oh, it's not the old line and the new line. It's point 1 and point 2. So like point A and point B. Each point has its own X and Y axis. Oh, dude. Okay. All right. I was imagining this. I was visualizing this whole thing wrong. Okay. Real quick. Let's go back here now. And let's see if what is being said there makes sense. So let's say we have 2 points here. We have a vertical line, right? We have a point here at -3. No, this is +3. So we have a point at, let's keep the numbers positive for the sake of simplicity. Let's say we have +3. Let's say we have +4 and +2. Okay. Oh, the music stopped. Okay. Let me just write this down. Okay. P equals 0 on X and 4 on Y. Q equals 0 on X and 2 on Y. Okay. So let's say M equals what would it be? If P would be considered, okay, so basically 0 minus 0, right? It's supposed to be Y. It's supposed to be the change in Y. So let's say just for the sake of keeping it positive, we do this, and then it's divided by, oh, yeah, because you're dividing by 0. That makes sense. Now it makes sense. So that's why it is undefined, because it is 0. For the sake of simplicity, let's call this 1 and call this 2. Okay. And so then we have x1, no, y1 minus y2. Or was it y2 minus y1? I don't think it's going to make a difference, will it? Okay, so it's y2 minus y1. So let's do this. Fine. So that becomes negative 2. And then x2 minus x1. And that is 0. So it becomes negative 2 divided by 0, and you cannot do division by 0. I'm guessing Python is going to give, it's going to say the same thing. It's going to raise an exception that you're dividing it by 0, but just for fun, let's try it. Wow, this is taking its own time. Give it a second. It's most probably gonna throw an error unless it decides to just give me a 0. Wow, this is really taking its own time. We are not going to wait for that. So we're going to move on. We can get the result later on. Okay, so this gave the answer. Well, no, wait. It stopped at 1 by 2 because, like, it was trying to... Okay, since the slope is positive, the direction of the line is increasing since m is less than 1. No, since absolute m is less than 1. Wait, no, I'm reading that wrong. Since absolute 1 is less than 1, since, fuck's sake, dude, since absolute m is less than 1, the incline is not very steep, meaning the incline is less than 45
A
degrees.
music app, and a fitness app, and more money for a bunch of other apps. That really adds up. So, why not get YouTube Premium for just one price? It's like having all those and the entire world of YouTube uninterrupted. Your wallet will thank you. If wallets could talk. YouTube Premium.
Okay, there we go. It gave the error, division by 0. Awesome. Cool. So, we just tested out the 0 theory. And I just also realized like what my mistake was with calculating the slope of a line. Now I'm kind of getting how because like you're not comparing it to a previously drawn line. For whatever reason, I kind of just imagined that you would be comparing it to a previous line. But no, it's just a slope between slope of a line, which you can pick any 2 points and get the slope that way. I need to test out if the order of the points changes the direction. But like in this context, what would direction mean? Like, because like when I say direction, I mean like, okay, is the line going from here to there, from here to there, or from there to here? Like, what way are we looking at it in? That's the way that I'm imagining it. Okay. Algebra and geometry. If y is a linear function of x, then the coefficient of x is the slope of the line created by plotting the function. Therefore, if the equation of the line is given in the form y equals mx plus b, then m is the slope. This form of a line's equation is called the slope-intercept form. And okay, y-intercept is something that came up in linear regression. Because b can be interpreted as the y-intercept of the line, that is the y-coordinate where the line intersects the y-axis. So where it hits 0, right? I'm guessing that's what it means. If the slope m of a line and a point so and so on the line are both known, then the equation of the line can be found using the point slope formula. All right, okay. Okay. Cool. Okay, in stats, do I need to read this? I don't think I need to read this. This quantity m is called as the regression slope. Oh, I probably need to read this. Yes, stats is heavily used in like machine learning. Okay, in statistics, the gradient of the least squares regression best fitting line for a given sample of data may be written as this. This quantity m is called as the regression slope for the line y equals mx plus c. The quantity r is Pearson's correlation coefficient. Sy is the standard deviation. And y values and Sx is the standard deviation of the x values. This may also be written as the ratios of covariances. Okay, I'm lost on this one because I had read up on standard deviation, but I forgot what it is, so I'm gonna have to read up on it again, and covariances as well. In all, I think I'm gonna have to explore slopes a little more before. Oh, the concept of a slope is central to differential calculus. For nonlinear functions, the rate of change varies along the curve. The rate of change varies along the curve. The derivative of a function at a point is the slope of the line tangent to the curve. Oh, the slope of the line tangent to the curve. See, the only reason I know about like tangent and the fact that like tangent looks like this is because I've done shader work, and like you do come across stuff like tangent, bitangent, and there was one more. I think it's normal tangent and bitangent. So like you come across those, and like that's one of the reasons why I know what exactly the tangent line is and like what it looks like. But like in terms of a curve, I still have to like study that properly. Okay. Give me a second. Okay. So I think that's gonna be it for today's stream. I'm gonna carry on reading this later on. I'm just gonna sit and relax for a bit, and after that, I'll carry on reading this. But once I'm done reading this, I think I can move on. I can go back to, where was it that I'd gotten stuck? Here, right? So then I can come back to this thing. And somewhere here, I should also look for, yeah, tangent. Let me just read up on that if there's like specific ways of calculating the tangent line. Yeah. I need to read up on this. But yeah, that's gonna be it for today. I was planning on raiding somebody, but like for some reason I'm having a hard time deciding on somebody to raid. You know what? Okay, I found somebody. So here's what I'm gonna do. I'm going to raid somebody. I haven't done that in a while. I kind of just stopped doing that. I just start my stream, do my thing, and then end the stream. But yeah, we're gonna do that. We are raiding someone called Perpetual Motion. So yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I will see you all next time. Peace.